All right, let's unpack this. Sorry about that. Let's unpack this acceleration formula here. And what do I mean by that? Let's do this. All right, so we know that the acceleration is equal to the change in velocity, v final minus v initial, over the time. Well, let's assume that the initial speed is 0 for the skaters. For skater 1, let's take Anna Doskova. All right. Let's assume that they were facing each other. They pushed off, and the push off, the time. So she was at 0. The time of her, the time that they were in contact with each other, let's just assume is 0.5 seconds. Okay, probably wasn't very long, but 0.5 seconds. I think that's a reasonable amount of time. All right. So what would be the final velocity? What speed would she be taking off? With what speed would she be taking off? Okay. All right. So let's take a look. We know that so we can just assume that I want to find v final. Okay. I want to change this to 1.5 seconds. Oh, yeah, they did a good push for 1.5 seconds. This wasn't a collision. This was a methodical push of 1.5 seconds. Okay, we're at 1,001.5. All right, 1.5 seconds. What was her speed? Well, you calculated her acceleration. The acceleration A is known. So if A is known, V naught equals 0, what do we have? We've got A is equal to VF over T. Do you remember the good old days when you had to get something out of the denominator and you'd cancel like this? Multiply both sides? Ta-da! Okay, so cancel on this side. So the final velocity, and this is where we write it in physics, the final velocity would be the acceleration times the time if the initial velocity is equal to 0. If the initial velocity is not equal to 0, we'll say that the final velocity is equal to that initial velocity plus that little boost that they got with the acceleration times the time of the acceleration. Okay? It's not hard. That's not hard. So you calculated the acceleration, which was pretty easy because you knew that F was equal to ma on her, and you knew her mass was 45 kilograms, but when we're trying to find her velocity, notice we don't need the mass at all. Or did we say 50 kilograms? We said 50 kilograms. Okay? So let's see if you can do the next problem. Let's see if we can calculate his speed.